Today on the IoT show, we'll talk about the integration of Azure IoT SDK into X-WARE and ThreadX, a real-time OS that is used in a lot of microcontrollers out there. And I have John Carbone with me from Express Logic to do that. Thanks for watching the Internet of Things show. I'm Olivier, your host, and today we'll be talking about ThreadX and X-WARE, which are platforms from Express Logic, and how they integrate into Azure IoT. And for that, I have John Carbone with me. Hey, John, how are you?
Hey, Olivier, great, glad to be here. Thank you for inviting us.
Thanks for coming. I think you've done the trip just for this recording, so really very much appreciate that.
It's important to us.
Yeah, where are you based right now?
We're based in San Diego, California.
Okay, sunny San Diego.
Sunny, but cloudy and fiery too, unfortunately.
Fiery
just
too?
like you guys.
Yeah. Well, actually, all good now.
Let's hope so.
And so you're here to talk about that integration that's been done between Azure IoT, which is our cloud platform, and the middleware you're working on top of ThreadX for embedded devices like the one you have just here, right?
Exactly.
So tell me a bit about Express Logic, about yourself, what you guys are doing and providing, and so that way we can actually set the context for that nice demo you prepared.
Sure, okay. My name is John Carbone. I've been with Express Logic for 15 years, and we were founded in 1996 when we introduced the ThreadX real-time operating system.
Okay.
It's an operating system that we targeted towards microcontrollers and microprocessors, small, fast, and easy to use were kind of the watchwords.
Okay. So what kind of, I personally know hard real-time systems and so on, but like some of our audience might not be super familiar. What kind of devices do we usually run these kind of real-time OS on?
Well, they can be a wide variety of devices, from very, very small devices, some sensors, some wearables, things like that, to office equipment like printers. HP is one of our major customers. Inkjet printers use our ThreadX real-time operating system. Avionics systems in airplanes and airliners as well. So it spans a wide range of functionality in the actual end product. But underneath all of that is a lot of common real-time operating system and middleware needs, whether it's scheduling, networking, USB,
it's not just the base scheduler that does the real-time tasks.
Now, back 20 years ago when we were founded, that's all it was. It was basically people would buy an RTOS and they'd write everything else themselves. And there was no networking really to speak of. So that came along and that prompted us to develop a TCP/IP stack. And then USB became very popular, so we developed software support for that. We have an embedded file system, and most recently, graphical user interface. So that, over the 20-year period, we added all of that software as middleware to complement ThreadX. And then most recently, we've added something we call the X-WARE IoT Platform. And that's a functionality that enables a device to communicate with the Azure cloud.
Oh, nice. Okay, so it's like you've been building these software pieces which were functional on the device itself, but now the era of connected devices and IoT cloud and so on, now you're actually connecting to these clouds.
That's right, and that's evolved over time. It didn't just happen all of a sudden.
I know.
We started with just the RTOS, and then over time, 5%, 10%, 20%, 50%, 70%. Now it's probably above 75% of our customers do some sort of networking. Same thing is true of USB and graphics. More and more people are incorporating those functionalities. So we developed this product.
But one more question before diving into that, because I personally think it's important to highlight the fact that ThreadX, the real-time OS, is still there to handle the real-time tasks. The ones that a Linux system or something bigger cannot really handle because it's not deterministic. It's not something that can handle a red button on a robot arm or something like that, right?
That's exactly right. Some applications require rapid real-time response. They require deterministic response, where you must respond within a certain short period of time. And Linux and Windows, no offense.
Oh no, absolutely not.
They were never designed for that. They're designed for a human interaction on a keyboard, and whenever it can get to a task, it'll get to it. But devices in the field, home security systems, avionics systems in aircraft, they need rapid real-time response. And so there will always be a need for things like a real-time operating system. And so that's persisted throughout all this evolution. We still see people just using the RTOS, and then others use some combination of the middleware as well.
But what you're bringing with X-WARE is all these software layers that are required to make that system more connected and smarter and so forth, right?
In specifically dealing with communications with the cloud.
Yes. Okay.
So if we look at our X-WARE IoT platform, it's got a number of ingredients. One is the RTOS. It's based on that. It includes the RTOS as a subset, and you can stop right there and just use the RTOS.
Okay.
But it also includes the functionality for networking, graphics, USB, and file system.
Okay.
And within the networking realm is really where we've put a lot of the value over the last 15 years.
Yeah.
And we support IPv4 and IPv6 protocols in the same software stack.
Okay.
We support high security protocols, SSL, TLS, DTLS, IPsec, for secure communications to the cloud. And most recently we've added a suite of protocols that are designed just for device to cloud communications, things like MQTT and CoAP and lightweight M2M.
And this is interesting because actually very often people assume that, oh, these are just software stacks that are out there, but we're talking about running that on microcontrollers that are very restrained in terms of resources. And also you need to have software stacks that will not interfere with the real-time operations underneath, right? So that's why you actually have to redevelop specific bits and pieces to do networking, to do security, to do protocol on top of all of that, right?
Exactly, and you've really touched on a very important point, and that's integration. One of the biggest parts of putting all these pieces together and making them work is making sure that they're all designed to get along well with each other.
Makes sense.
You know, you can throw a lot of people into a house that may not all get along with each other, and individually they may be great, but heads clash. Well, we have to make sure there's no head clashing between our graphics system and the network stack, for example. We don't want them both going after the same resource at the same time. So we make sure that there's no inconsistencies among all the elements. We make sure they're all ported to run on a particular piece of hardware, whatever that hardware might be. And so our customers, our combined user community out there, can purchase something off the shelf that they know will run on that device that they've chosen, and it will perform these functions for their application. And they don't have to worry about buying separate pieces. They don't have to worry about integration. We'll have support, we have documentation.
Makes sense.
We have a website, rtos.com, which is a great place for information about all of these topics we're talking about now. So that would be a good thing to leave people with at the end, is an invitation to go visit us there.
We'll do that. We'll add that to the description of the video here.
Yeah, so with all this capability, we've coined another term. Our X-WARE IoT platform is one term, but the other term we've coined is industrial grade.
Okay.
We thought about what can we say to characterize our software versus other software that you might come across in the marketplace. And there's some software that's good for prototyping or hobby development or for experimentation, R&D perhaps. But our customers want to put our software in devices that the company is betting on, like HP, for example, on their inkjet printers. You can't have something malfunctioning in millions of HP inkjet printers deployed.
You cannot have something flaky. You need to have determinism in there.
It's got to be reliable. It's got to be dependable. It's got to be correct. It's got to operate efficiently. So we make sure about all of that integration, and people come to us for that kind of software. So we thought, well, what can we call that? And we came up with the term industrial grade, because it really implies a strength.
Yes.
It's software that is used by industry, not used so much for education or hobby development, which are great, but no, we're aiming at the customers who bet their company on their products.
So they want providing a guarantee that the thing's going to work, basically,
and we characterize it, so people ask us what makes a product industrial strength. Well, we say it's got to be small, safe and secure, and advanced, fast, and easy to use. All of those characteristics. And if you go to our website, rtos.com, you'll be able to see how we feel that we meet each of those characteristics with our X-WARE IoT platform.
Makes sense. Makes perfect sense. Like it.
Great.
I'm sure you have. Do you have something else before the demo to jump onto?
Well,
I think you do, right?
Kind of an overview of the architecture.
Of how things are working before demoing them.
This is sort of the world of the IoT in a simplified form. And here we have the devices that might be existing. It's whether it's a light bulb controller or a fan or a thermostat or an avionics system or whatever it is. There are all these devices. They range from pretty simple to very complex.
Yep.
The devices themselves have some in-device needs. And this is an important point because when people think of a cloud and the IoT, they tend to focus on the second piece of this triad, and that's the device-to-cloud communication.
Yep.
But the device-to-cloud communication is only one part of it. You've got to do something in the device. The device has responsibilities.
Yeah, and connectivity, one of the scenarios is might not always be there.
You might not need to be, you might need to operate separately and
totally.
independently for a while. So that's where X-WARE IoT Platform comes in. It satisfies the in-device needs of the application from simple to complex.
Okay.
It also provides the device-to-cloud communication.
Okay.
And then Azure comes in to provide all the capabilities of the cloud.
Got it. Okay. And so the X-WARE platform, I would assume, comes with a set of APIs that developers can leverage so they can build their apps on top without having to redevelop these common stacks like for USB and graphics and so on, right?
One of the things that makes X-WARE IoT Platform attractive is that all the elements of it, the networking, the RTOS, and so forth, they all follow a consistent, intuitive API. And that's part of the reason it's easy to use. Because once you learn one thing, once you learn how to program the RTOS, it's very easy for you to transition that to working with the TCP/IP stack and the graphics. All of the elements have the same intuitive API structure. But what we've done for Azure is to integrate with the Azure porting layer. You know, Azure, the IoT Hub in Azure comes with a porting layer that enables applications in a device to take advantage of the power of Azure, of the cloud.
Yes.
And they can do that through your API.
Yes.
Now your API has to run on a particular piece of hardware. That's where we come in.
Okay.
So we've mapped your API calls to our API calls that will manipulate the device to perform the necessary functions.
Makes sense.
And so that all kind of fits together that way. We bridge between the application need and the device, and we provide access to the cloud at the same time.
And so when we're talking development on these kind of platforms, we're talking C, C++ development, right?
C, typically C. We have a vast majority of our developers using C. Some of them use C++. Very little else.
Yeah, we are, and that's why you're using the C SDK of ours, right?
Exactly.
Totally understand. No, that's nice and neat. I guess what people want to see now is a short demo, right?
Okay. Before going to that, if I could, I'd like to spend just a moment on the topic of safety and security.
Yes, agreed.
That is such an essential part of today's IoT. And it's going to be even more essential as time goes on. So there are safety and security needs, and I invite our listeners and our viewers to visit rtos.com and look at the details, because we don't have time for me to go through all of these, but we have a large number of safety certifications that has been achieved for not just the RTOS, but also the network stack and the other components of the platform as well.
So when we hear safety versus security, can I just translate that into safety is about the guarantee the things are going to be safe, are going to be working, going to be reactive, and you basically comply with a set of certifications and regulations that are out there, right, for various industries.
That's true.
And security is more like towards being prompt to respond or to block attacks, make the device more robust, and so forth.
Pretty much. There's a tremendous overlap because both safety and security depend on the integrity of the software. They both depend on the software doing what it's supposed to do. So when you're seeking certifications for safety, you have to prove to the certifying agency that your software does operate as intended. And they do a rigorous static analysis of all your code. They look at our development practices, our coding standards, our test procedures, and whatever. Not just the code itself, but the whole company gets examined.
Makes sense.
For security, it's much the same thing. A lot of the same things are examined to try to assure that your software can withstand attempts to subvert its purpose. But the thing that differentiates security is the concept of encryption. Encryption occurs for security, not so much for safety. So with security, you need support for all the various crypto schemes that are out there, RSA, SHA-2, AES, and so forth. to make the data secure from attack and from snooping and sniffing when it's being transmitted between the device and the cloud.
Okay.
And so that's what differentiates the security from the safety. Otherwise, there's a great overlap between what the two of them demand out of software. Makes sense.
And in general, I would say for a customer, using X-WARE actually is a guarantee that if they have to comply with that or that, regulations, then they can by default assume that it's all good because you already have these compliances.
That's correct. It saves them the trouble of certifying it themselves. If you write your own RTOS, for example, and you require a safety certification, you're going to have to provide all of the same documents that we've already taken care of. And some fault may be found in your RTOS where it doesn't quite meet the requirements, and you have to go back and fix it. We take all of that risk off your hands, we take all of that time and energy away, and we give you something that's already been pre-certified. You simply present the certificate to the certifying agency, and they say, fine, check off the RTOS, check off the communication stack, check off the USB stack.
Okay. Makes sense. Love it.
So make our developers' lives easier.
Make our developers' life easier, and they could sleep at night.
That's the whole objective.
I like that. Okay, now the demo.
Okay, can I show you the demo now? Okay, very good. The demo is a simple example that's based on the anemometer example in the Azure IoT Hub porting package. Okay, so with that, we have a ST Micro 32L 475, if I have the number correct off the top of my head.
I'm sure you do.
And it's a very small device, very limited resources, which is an excellent fit for our X-WARE IoT platform.
And we know ST Micro chips are in a lot of existing products out there already.
They're all over the place.
Yeah, they are.
And so what we have is an application that's going to subscribe to a topic and publish data to a topic.
Okay.
And then we're going to subscribe to the same topic through the Device Explorer.
Okay.
Now we could use another piece of hardware, but since I only have the one and we've set it up to look at it this way because this is actually more visible to users. So here we have the Device Explorer, and I've already populated the connection string, so I'm going to update that, and that's been successful. And now we'll generate SMS for it.
Okay.
There we go, and we will now check and make sure that it shows that it's been connected. And so here it is, and we chose connected.
Okay.
So we can go forward to monitor the data. Now there's nothing yet. Oops.
Oh, it's calling. It was not selected yet. The device ID was not selected. Okay. Yeah, there you go. Should be fine now.
Operator error.
No, actually, I think the tool takes some time to refresh the list of devices.
Okay.
So when you bring up that tab, basically it looks into the IoT Hub for a list of devices, and then displays one, and the only one will select by default.
My fault.
No, you're good. You went too fast.
I'm too fast. Okay, so the first thing we have to do in this demo is to put it into either what we call timer mode or user mode.
Yeah. So what did you have to do for provisioning the device with the right piece of software? So there's that X-WARE integration with Azure IoT. So that means that a developer, what does he need to do in order to run the code on that device, leveraging that integration?
There's a bunch of code that goes along with this demo, which in fact is downloadable from our website.
Okay.
So customers can take a look at it themselves.
Yeah.
So the best way to answer your question is that we provide all of that source code to customers so they can see exactly how they access the Azure API. And they really, for the most part, just deal with the Azure API.
Yeah, just basically creating the client, connecting with the connection string, whatever security information.
The security is taken care of.
Yeah, and then you just send it
publish, subscribe,
yeah.
and things like that.
Makes sense.
So it's quite simple.
Yep.
So here we have a message to be sent, and I'm going to set up timer mode first. In this mode, and then we'll go back and watch the data that's coming in. In this mode, the device is going to publish a temperature message once every 2 seconds.
Okay.
And it'll increment the temperature by 1 degree each time.
Each time.
We can give it a turn fan off and turn fan on command, which will either cause the temperature to decrease or increase. So right now, by default, the fan is off. And that's simply now a demonstration of the board under control of a timer is publishing data, and we're subscribed to the data here on our window.
And interestingly, you've been using cloud-to-device messages from IT Hub to configure the device from the cloud. And the device immediately reacted, set into that new configuration, and then started sending the messages using device-to-cloud messaging.
Exactly.
Okay.
All right, the next thing we're going to do is change to what we call user mode.
Okay.
And user mode operates differently. It resets the temperature to 20, to the starting point. And let me go back to the data. I'll clear this. And user mode is going to wait for me to press this blue user button on the device. And every time I press that button, it'll publish a message with the temperature and increment it by 1 each time I press.
Makes sense.
So
now you have a direct tie between the hardware events and the send message
and the
to the
publishing,
cloud.
rather than an internal timer. There's some external event. And
Okay.
of course, these are just examples. It could be anything to trigger that.
Yeah, so obviously from there on, like someone using that board with that sample and X-WARE and Azure IoT, basically they can implement whatever they want.
Absolutely, and that's what all of our customers do with our examples.
Great.
We have a whole bunch of them on our rtos.com website.
Okay.
And whether they're IoT related or just an embedded system, starting with an example makes life so much easier, because you can just take out what you don't need and add what's not there, customize it to your own specific application, and you're off and running much faster than if you had to start from scratch.
Like that. Well, John, I think that was a great insight into X-WARE, what Express Logic is doing, and I hope to eventually see you soon for other demos like that.
I love it.
You're welcome. And thanks for watching the IoT show. We'll add the link to rtos.com, which is the site where you can get all the information. And don't forget to subscribe for the show as well. Thank you, guys.